Welcome to ElitMind podcast, ElitTalk. ElitTalk is a breakthrough technology, AI and ML, data and cloud-oriented podcast created by top experts in the field of MDW solutions and analytics. Together with our guests, we present the newest updates in leading technology vendors.
Hello and welcome to ElitTalk podcast. My name is Andrzej Ermel, I'm Digital Strategy Executive at ElitMind, and together with me today we have Przemek Wiesiołek. Hello Przemek.
Hello everyone.
Przemek is our data science team leader, and today we'll be talking about quite a complex topic, I would say, maybe even a little bit broader, a concept that is called feature star.
Yeah.
Przemek, this concept is quite new. There is a lot of discussions around this topic. Why do you think so? What happened on the market that currently we are talking about?
Market has changed a lot during the last 5-7 years. While 5-10 years ago we were mostly in the experimental phase. Companies were doing a lot of POCs and experimenting with what kind of model might help them in the business. That now they are actively implementing ML and AI services in their workloads, and there is a higher and higher need for ML and advanced analytics in the business. So we can say that ML become integral part of core business. For example, in energy sector, there are a lot of examples of where ML came inside, like forecasting energy from renewable energy sources is a must now, because without it, it's not impossible to drive this business.
Yeah, I would say even that we used to have data warehouses teams, business intelligence solutions, and people or whole teams who were built around this. And that's the next step that we see. Almost every bigger company has one, two, or even whole teams of data science already engage in all aspects of the business right now, right?
Yeah.
You said that machine learning is becoming more professional. Why? You said that machine learning is becoming part of core business processes. I agree. But from the perspective of this being more professional, what do you see? What kind of impact that has on our approach?
Yeah, basically, as I said, we were in some experimental phase, and now it's part of the core business. So companies need more models, faster deployments. They are using it everywhere. So time to market or time to value for the data science projects become a crucial KPI.
That's a very good point that I think needs to be emphasized, because usually when you are leaving the area of experimenting and when the real business becomes the vital part of your operations, now the time of the project itself becomes crucial. And you mentioned the KPI, which is called time to value or time to market. What does this KPI is talking about?
Yeah, this KPI means how much time do we need as a company from the when the idea arises to the deployment. So, okay, we have idea, let's optimize something in our business. We can use maybe some predictive model. Then we need to find data, make some ingestion, some other steps like exploratory data analysis, statistical analysis, etc., featurization, and there are multiple steps. And it is basically called data science life cycle. And it used to take a lot of time from the idea to the deployment. And now what company needs in this very fastly changing business is to shorten this period as much as possible. And what we see, if we look in this model life cycle stages, we have data preparation ETLs mostly, which are widely known, and we do it for a long period of time. So there is nothing to optimize. But then we have featureization, feature engineering part, and this is the part where it's very common in our business to say that 70 up to 80% of data scientists' time goes into featureization. So it's obvious that we can optimize something here.
What is feature itself? Because I agree, and everyone is talking about this all the time. 70-80% is data management, data preparation, and you split it in what we classically understand as ETLs and data preparation, let's call it, and featureization. So what is this feature that you're talking about?
Feature can be anything. It can be anything that is required for your model. It can be some aggregation, some calculation, some metrics. It can be calculated for your customer, for your product, for whatever. But it's required for your model. So, for example, if we take look into the banking sector, the feature is account balance on the end of the month. The feature is number of credit cards owned by the customer, etc. Yeah.
So it's a type of calculation or type of information that is the result of calculation that then is taken by the model to work, basically.
Yeah, exactly.
Okay, and from the perspective of this process, of this featureization, so feature store, featureization, we got some commonality of names. What is important from your perspective right now?
We see in many companies that they are dealing with common problems, like they create features, but those features are not reusable. It means that some data scientists come up with idea how to calculate something nicely, and they use it for one model, and it's not stored in some central point that can be accessed by everyone. Whatever, if in big companies like enterprises, it's often that they have multiple data science teams. Yeah, another one is for optimizing marketing, another one for optimizing sales, for example. Yeah, exactly. So what we observe is those teams are not cooperating. Each team is doing featureization separately. So there is a place to optimize. And I think that you are going to the point of feature store. How can it help here? Yeah.
But when you are talking about these examples about what is feature and what kind of problems with sharing in bigger organizations, from my perspective, I start to thinking in terms of classical BI, what kind of problems we have when we are doing, for instance, some kind of KPIs reporting, right? Very often we have a definition of KPI, what is client or whatever, what is kind of sales. And we cannot agree within the organization even on the same definition. And then when we see the reports, it looks like they are talking about the same thing, but actually they are calculated different. So here we have exactly the same thing, right? The only difference is that the consumer of those KPIs or those features that we are talking about are models, but not the particular people.
Yeah, exactly. Different teams defines the same things, the same features differently, gives different name, and of course it's quite often that companies have very poor documentation, so it's very hard to cooperate in effective way.
I see also one more, maybe the last but not least, a challenge on the market right now, that with the introduction of machine learning so broadly throughout the business processes, that we see a huge regulatory pressure on handling those features. It's especially visible in the financial markets when you have a credit scoring model and you need to explain exactly how this model works and what kind of data it is using. So I think we have a set of challenges that are revolving around the same topic. Okay, so potentially we know that feature store may be the answer. So what exactly is this feature store?
Yeah, feature store may be the answer, and it's just to sum up this what we just said. We can say that managing features, managing data, is a significant challenge in ML today, and that's why feature store as a managing tool helps here. So basically, what feature store is the answer to the challenges on the market. And from the technical business point of view, it's a collaborative platform to manage, store, and provide access to historical and real-time data.
Right, so it's collaborative platform, right? I know that historically, feature store, if I remember correctly, was the concept that was introduced by Uber, to be honest. Because they were the first among other big tech companies which actually dealt with the data science at scale. So if we are looking at the timeline, the first feature store terminology arrived, 6 years ago. And then it was slowly adopted by more and more companies. At the beginning, big companies, because that's how the data science adoption basically went through. You said it's collaborative platform. What do you mean by that? So
it's collaborative platform because it allows multiple roles, multiple people to collaborate. What I mean by multiple roles, of course, data engineers, because they are responsible for creating and managing those features in feature store. Data scientists. From the data scientist point of view, feature store is like a central repository of features. So it enables them to find, to share features, and it ensures that the same code is used to compute features for a training set and for the inference. So that's an important thing. And the third group that is involved here in this project, in this part, is our ML engineers, as they are responsible for productionizing ML or AI models. And that fits very well to what I previously said. We are putting effort to shorten the time to market. So feature store is a concept which makes it possible, makes people working together more efficiently, and allows them to deploy models much faster.
It's very interesting what you said, because if we compare historically, they were separate teams working on separate set of tools and even working on separate code. Because I remember very clearly when we used to have on very different platforms data engineers who were doing at ETLs, data scientists who were doing something, nobody understood what they were doing. And then the result was some kind of model that was passed to machine learning engineers who have to recode basically everything to make it ready for production. And what we are fighting here is to work on basically the same set of code, the same set of definitions to be common among those three teams.
Yeah. We all quite often say that feature store is like a bridge that gap differences between all of those roles involved in creating advanced analytics.
Mm-hmm. So we had those discussions for several years. So from your perspective, or as an ElitMind, what kind of functionalities do you see that are crucial for this feature store platform?
I think that consistent definition of features is the top one because, as I observed in many companies, it's not so obvious. As I said before, different teams defines the same things differently. So it's important to define across the whole organization things in the same way. That's the one point. The second point is sharing features. That's what we also mentioned before. Sharing features between teams, because reinventing the wheel is not necessary, but it's happening in real life in organizations because they work separately. The third thing I would say is auditability of the process of creating, generating, using feature. Some kind of lineage between the sources and the models is needed. It helps to,
because you can share, but you need to have an information. Who did you share the features with, and how, and when?
And who is using that feature? There are many things. So
if we are talking about auditability, this is also a regulatory requirement, right? Because of course you can create some table and make it usable by others, but you have to have this trace of these logs of how this data were consumed. Anything else from your perspective?
Of course, CI/CD support. It's something that is getting more and more popular. If you want to be very professional in data science, we need CI/CD processes. That's obvious. And scalability. Scalability, what we observe in companies, it's they don't have 100 features, 200 features. They are having thousands of features, 10,000, 20, 30,000 of features. So solutions must be able to compute such amount of features to serve with appropriate latency. And the last thing, which is maybe the most important here, is that, and that's the answer on the question, what's the difference between normal database or data warehouse and feature store? Because someone listening to us may think, okay, they're talking about data warehouse. What's new here? So the general difference is feature store has two layers. It's a dual database. What I mean by dual, there are two parts, offline and online. Offline feature store, mostly column-orientated, is used to store large amount of data for training processes and for monitoring processes, and of course for batch scoring. While the second part, the online feature store, which is mostly, in most cases, row orientated, is used for serving features with low latency. So the obviously is used for real-time services application scoring.
Yeah, you can think about that also. How does the process of creation and using machine learning models looks like? Because when you are training the model, you are basically using as much data as possible. You are trying to incorporate all your history of data related to your business problem. Therefore, you need some kind of big data storage and big data scale of operations in order to make the model as precise as possible. However, especially when you train the model and you want to make an application out of that you are scoring the model, so you are using the model in real-time situation, you are not using the whole history. You are using a particular point of the data, and then the latency becomes the king. So here we have quite a juxtaposition between two different database engines that you need. On one hand, giant scale whole full history. On the other hand, super fast latency for real-time responses.
Yeah, and there are real use cases for this super low latency. For example, websites with some dynamic content, which are chosen based on some ML models. So the latency must be really low, much lower than 1 second. Let's say like this.
Recommendation engines on the pages, right?
For
of the
example,
products.
yeah.
This is, you train the model based on the history of all the clients and their behaviors.
Yeah, and then
But in real life, when you are going through the web page, it has to happen instantly.
instantly, exactly.
Right. So, so this is, let's say, the perspective of functionalities that we see that are required. How did you translate those functional requirements to the technical one? Because at the end of the day, you have to use some kind of technical solution for that.
Yeah, and there are many aspects of technical things here. So let's start from scalability. As I said, it's getting more and more required by companies. And in ElitMind, we think that the best feature store provided on the market is by Azure Databricks platform. And Azure Databricks platform is based on Spark. What's funny, founders of Databricks are the same guys who invented Spark, so they're really good at it. So yeah, we have inherited scalability with the Spark on that platform. And of course, Databricks enables batch streaming and real-time processing transition of data, as the Spark and Python allows you to do whatever you want with this, and provide a lot of libraries that support this. Another thing that is cool in Azure Databricks is Lakehouse, which lies in the basis of how the data are modeled and stored in Databricks. Lakehouse is built from data tables, which are really cool. For example, they support time traveling, which allows you to do point-in-time lookups. So you can take data from the history and use it in your scoring, use it in your training process. So
this is the basis for auditability or the tracing of the model drift, right? Because since we are having the history of the data that is stored and how it was changing, we can be quite sophisticated in terms of monitoring how the scoring or the behavior of our model is changing with arrival of new data, with updates and so on and so forth. From the Databricks perspective, we also see, and maybe you can elaborate a little bit on that, we have something called ML Flow. So if you could...
Yeah, ML Flow is, I believe, the most popular framework for MLOps in the world. It's also created by Databricks. It supports multiple things, but what is really important in terms of what we are discussing, it's experiments, ML Flow experiments, ML Flow models, and ML Flow model repository. Those three parts of ML Flow helps you to deliver model faster, to debug whatever problem you have. And what is really important, it's log everything you did. So you can come back to your history of your experiments, of your runs, reuse it. It also helps you to retrain the model based on what you did previously in the primary model and what your data drift, for example, or target drift is. So yeah, and ML Flow inside Databricks and Databricks itself also provides something called model serving. So that's fascinating because with I don't know, 3-5 clicks, you can productionize your model. What by productionizing model I mean creating endpoint, which can be used for real-time scoring.
Yeah, so basically, the way I look at it is that not only you have a nice place to deal with data storage, data processing, and so on, you already have a fully developed metadata framework to handle those auditability, these logs, these organizational issues that we were talking about. On top of that, we have a Unity catalog, so every topic related to the data governance and machine learning governance already built in as well. So I think this is not an accident that why we were deciding, we really were looking throughout the multiple technologies that were available on the market, but currently Databricks was the closest one to tick all the boxes that we were talking about from the functional perspective, but also from the ease of use and having everything in one place in one service is something that we really appreciate. Right?
Yeah, exactly. And one more thing that we need to mention is serverless, which is available in Databricks. It allows you to serve your features, serve your model without need for creating compute. You can do it just by the serverless. So in a second, they are available for everyone across your organization.
Yeah, and to emphasize that serverless model serving means, as you mentioned, in 3 to 5 clicks, you are basically building a mini application with endpoints that you can trigger and basically have the model live to integrate with any other business process that you are thinking about. All right, so we are not talking about future stores purely in theory, because for the last 1 or 2 years you are heavily involved in implementation of those platforms. Can you talk a little bit about what you are doing day to day, basically right now?
Yeah, we have great project of analytical platform implementation in banking sector. Analytical platform that needs to fulfill a lot of requirements, starting from the KNF regulations, the lower regulations, because it's banking sector, so it's highly regulated. But it's also a lot of requirements related to the scale.
So what is the scale that you're doing?
What is the scale? Our solution is optimized for high performance, and it can operate up to 70,000 of features without any loss in the performance. How we achieved it? We use Spark, we use a lot of parallelization, and we also used a lot of best practices that we developed in the ElitMind during last years. So we are putting our best effort to optimize it, because computing 60,000 features every day in limited time, and those calculations are not only sums, minimums, maximums. Some of them are really complex. Those are all trends in some time window. So it's really time consuming, but we optimize it as possible.
So just for me not to lose it, you mentioned regulations, KNF regulations. That is also one of the reasons that we are choosing Azure Databricks as our platform, because as most of you who are listening probably know, banking sector basically requires full ISO, at least 27001 implementation, and it's possible here because Databricks, first of all, is available as platform as a service, so it can be spun on the client's tenant, but it also enables us to fully secure it from the networking perspective, from the Azure security benchmark perspectives, full encryption of the data and so on and so forth. But what is also important, and we mentioned a few things about that already, is this auditability and traceability. Because any model in the banking sector has to be able to answer the question, how was it built, and what kind of the data it used in particular point of time. This, in principle, requires all those features that you were talking about to be combined together. So CI/CD, time travel from the data storage perspective, full auditing that is related to feature creation, model creation, model monitoring.
And I think that it's important to mention here how we created feature story in that organization, because it's creating 60,000 features is not like writing 60,000 SQL clauses. The process is it's a metadata driven process. With a lot of configuration, which allows to choose period of in time windows, choose type of aggregations, choose some even custom aggregations, custom functions. But what is important, it's all configurable. So we always know how each feature was created, based on what definition, based on what time of period. So the way that we do ETLs in pipeline way normally, it's the same what we implemented in feature store. Everything is log, everything is driven by metadata, and everything is auditability by this.
So to sum up, basically the feature store is an extension of data warehouse, because there is a part of data warehouse inherently, of course, at the beginning.
Yeah, it's always called data warehouse for data scientists.
Exactly. So we add additional functional requirements that we discussed, primarily related to expansion and nice calculations of those features that are used for machine learning. We pack everything in MLOps process in order to have information about everything in every possible way, basically. We add the CI/CD in order to have a control over the code in such a way that the code used to create features is used further down the line to create models and to do the scoring. And on top of that, we finish by using serverless for deploying the models to production. And this is basically the whole data science lifecycle encapsulated into one platform, multiple quite complicated processes, but at least enabling us to handle this scale, as you said, 30 to 60,000 features to even deal with. So that is the feature store, but from what I gather, when you are doing your projects at ElitMind, you are also expanding this framework even further, right?
Yeah, because feature store itself is just feature store. We need to use it by some other processes. And as I mentioned in this banking sector organization that we implement analytical platform, we prepared few other machine learning processes like automatic feature selection, like model factory. So the thing that is it's configurable, but it's automatically train, optimize, and promote model. And there are some additional parts like automatic retraining, like monitoring, things like this, which are supporting the main processes. So the main, we can say, the feature selector, of course, and model factory. And all of that was possible because we have feature store. Without feature store, it would be really hard to create such process with so many steps, so complex, and do most of the things automatically.
So maybe to sum up our discussions today, from our perspective, it looks like that. If you have a situation when you are dealing with data science at scale, when you are doing multiple data science projects in your organization, you need control over this, and you are trying to optimize for time to value, then we really recommend to take a good look at this concept, because it even doesn't stop there. Because going through the whole data science lifecycle, we feel that feature store is a basis for further automation even down the line. Even the model production itself can be automated, but with the feature store as a stepping stone. Other elements we will probably discuss later in the next discussions. Thanks, Przemek, for today, and I hope we inspired you to explore this feature store concept.
Thank you, guys.
Thank you.